Right. So, good morning, all. My name is Pankaj Deore. We're going to talk about a little bit about AI and machine learning in testing, along with how do we really have the reporting and metrics when it comes to the quality engineering. I'm specifically using quality engineering, not a QA or testing, quality engineering. So we'll see how those metrics going to help us in terms of implementing all the matrices and then benefit you and the your readiness. So quick introduction for us. So today Vikas and myself is going to put together for AI in testing as well as reporting. We've been in the industry almost for 18 years and looking at different variety of automation as well as your mobile automation, and process automation as well. So what actually AI is? So have you seen these kind of advertisements sometime before? Like your brush is smart, AI enabled, your thermostat is AI enabled, where it will control your room temperature and everything else. I would say those are not AI tools, those are smart tools. They have some if and else conditions applied, some program is done. So how it is, like you have a rule and you have a data and you get the answer, right? That's your traditional programming. How about where the AI comes in picture? Just remember, rule, data equal to your answer is your traditional programming. In AI, it's like you have answer and you have data and you generate the rule out of it. That is your artificial intelligence. In fact, artificial is something which we generate, we create, right? And intelligence is something which human already have it. So we combine that to develop a automation where we try to make AI. But is it a really fact? Is it really possible? This is what you can think about right now, right? This is your AI. The expectation is like, the robot should do everything for us. And then, the reality is actually it does not, right? It actually just focus on some programming, some, inputs that we give as a data, and then we move from there. The further we can see the good example is this. In 90s, we thought of AI would be like boom, and then we'll have everything been automated, everything been taken care. We don't have to write automation test, right? But the reality is, it's like you can see it. I don't know whether you can see it. This is dog. It's actually a cat, right? So how this happens? Why this happens, right? Is it real? It's a reality, or it's really just a hype about the AI and machine learning? I would say AI exists, but at what level? That's what we're going to see today. So what actually the AI means? There are various definitions been defined by a lot of smart people who have been studying on artificial intelligence. But AI means is a very simple definition. You mimic a computer, behave like a human, right? That is AI. It's a very simple definition. That's where AM Tutor actually started in 1950s. He had written a document on AI, what is artificial intelligence in computer, right? So that document probably give you a good idea about it, how AI should function like it. It's not just for the testing, but overall as an industry. What is machine learning? It's like it's a subset of machine learning that gives you AI, this is very important when you say that, explicitly programmed, right? This function which is explicitly programmed is called as a machine learning for computer to behave like a human. And there are different models or different I would say learnings, machine learnings that have been followed. For example, you have a linear regression supervised. We're going to talk about those in little detail with some examples. So there are linear regression supervised learning model, which actually it's like an equation, right? Y equal to x plus 1. So you're going to give the value of y, you're going to give the value of x, and what is the equation is going to give. Like for example, if you have maybe weight versus height, right? So if you know that if you're going to put some weight, as soon as you
put the value of height
and value, yeah, it increases, right? So we'll talk about those little detail. So in gist, this is what is your AI and ML looks like, where you have, artificial intelligence is actually asking machine to, act like a human, whereas the machine learning is a subset of AI techniques that is use all the statistics method to enable your machine to act like a human. And top of it, you have a deep learning. Okay, so this is something is always confusing to all of us when we talk about AI and ML. So deep learning is something which is actually a complex program that actually needs to be converted into your machine learning language and then used as an artificial intelligence. And that everything has been supported by data or data science. So this is what I'm talking about. So machine learning categories. So there is a supervised learning category, and we have some models there listed there. Which model can be helped to, go through the supervised learning? Supervised learning is something that you actually tag your data. You give some parameter to your data to identify that, okay, this is the data. For example, think about your Google Photos. When you take a pictures, it actually tag with the location. And when you go through the photos, you just actually see, I want to see what photos I have taken at Salt Lake City. And then you just click on that and you see that. So those have been tagged. And then that's based on that, we actually see those photo or categorize those photo for the same. The good example is another is like flower, right? You have you can give a petal size, shape of the flower, color of the flower, and then you can find out what species of that flower is from that data, because we tag those data accordingly. Unsupervised learning is something where you don't have to tag the data. This is again important. But what it does is it goes with the patterns. You have a different patterns, and based on the patterns, it actually use the algorithms to find out the classification of that. Example is like music libraries. Like we use Apple, Android, or Spotify, and we you want to listen to a song which is mostly emotional songs, right? Let's say sad songs. So how it categorize that? Are we really categorizing, tagging those songs? No. So that's where the it classifies, puts the pattern around it. It goes through all the songs and categorize those, and we can really hear those songs accordingly. So reinforcement learning, which is again a trial and error, scenarios where you can actually learn from your errors. Best example is like your chess game, right? You play chess and then it goes with the patterns, and it understand what your probability of moves or predictability of moves, and then it actually learns from those errors and actually builds some patterns around it, and then every time it corrects the error to work with that game. So that is reinforcement learning. So when we talk about deep learning, it's actually part of each section. It comes under supervised, unsupervised, and reinforcement. Oh my God! Reinforcement learning. So this is the mainly categories and use cases where you can find machine learning. Yeah. So let's talk about what testing we can do in using artificial intelligence. And there are some demo and examples we have done with the mobile app. So probably because you can talk about that.
Of course, thank you, Pankaj. So let's talk about AI. Thanks, Pankaj, for explaining what is AI, what is ML, and what is deep learning. So let's revise quickly. AI, it means anything that computer does a smart thing or mimics a human behavior, not necessarily that you might be using only machine learning models. Second one is machine learning, where you train a computer to mimic the human behavior, so it will take its own decisions and predict. And the third one is the deep learning, which is again used to solve the complex program which uses multiple models in a combination, for example, a neural network, and then it tries to solve a problem. Now, where we can use AI in testing, there are multiple applications, where we can use AI in testing. We already talked about hype versus reality. Don't expect that we have an AI, just provide the application URL and you will get automatically test cases written, getting executed, and you just find a bug automatically. No, we haven't reached up to that level yet. So I will be talking about AI in testing in general, and then I will show you one example. So first one is using a visual testing for AI. So how many of you have heard of Applitools name? I'm sure most of you, right? Because they are pretty good with their eyes library, right? To identify elements on a screen or performing or simulating an actions on app. But again, that's again, don't expect that to write all automation test cases for you and getting a bug ready-made. Okay. Second one is API testing. The problem with API is when we develop an API, it may follow hundreds of different rules. We call those as a schema. So we have a schema, but whenever we get a time for automating an API, what we generally do is we go with the happy path testing. We provide all the valid data first and then check, what is the response, and this is how we test, because we won't be able to test all the hundreds of the rules which are mentioned in a schema. What you can do is you can validate the response with a schema, but that is not really a testing. So for that, you can use an AI to simulate that test data and then make those API calls based on the schema. So that could be another application for AI in testing. Third one is the test maintenance, which uses a self-healing capability. If one locator is failing, switch back to other one, which has the highest confidence level, which is another good example. And that's generally called as a self-healing capability, and that helps in reducing the test maintenance. Third one is the test data generation. There are right now, some tools, they, take the application URL, go through the form, find out this text box is the email address and this text box is for SSN, and then generate your test data accordingly, randomly. You just provide how many sets you need. So test data generation could be, this is also using an AI. And then last one is the most reliable the test cases. So the most reliable test cases, this is kind of a holy grail of automation testing. I just give my application URL. It will write the test cases. If some changes are happening in application, it should automatically modify my test script, with respect to a change, and then execute it and get the bugs. There are some tools which they claim that having this capability. For example, there is a tool I have added a link in my presentation, but that's opkey.com. For example, if Oracle is about to release or they have released a new version, they also tells us what are the changes they have done in their module. So AI should be smart enough to just read the change log, go to those specific test cases, update it accordingly, and then run your test cases. So we basically reduce kind of a maintenance here. This is the current trend. What are the current companies which are already there in testing industry? They are sponsoring or they are marketing their tools as an AI. I'm not saying any company bad or good. They are very nice companies. They are doing pretty good job, as the definition of AI is not only limited to one particular thing. So it could be anything which basically helps us in automation testing. So Applitools simulates AI. TestIM, we already saw a demo, not demo actually, the presentation earlier in this same conference. Perfecto, UFT One. UFT One is, if you're not knowing, QTP is now known as UFT One. It also has that UI capability to simulate, to take a screenshot and find out the elements and perform actions. So the latest version of QTP UFT One, it is now owned by MicroFocus. Tricent is Tosca, the UiPath, the RPA tool. They do also have AI capability at some extent. But what I am here today is for a demo. I would like to see real AI into my code. So that's why I'm here. So how many of you are really excited for a demo? Because everyone talks about AI, but when it comes to demo AI, it's kind of hard, Anyways, I will try my best. I haven't written any AI model, but I will try my best to help you guys to understand where you can actually use an AI and or what is the current state of AI into testing. So what is the demo is about? I will be trying to solve one problem. The problem statement is XPath and CSS. Do you agree that XPath and CSS is actually a problem, or the locators itself is a problem? I say locator is a problem. Some people say locator is kind of a way to interact with the element, but which I don't really think so. It's basically the problem. It's kind of a root cause for my failing test cases every day, because the locators are changing. And why? It's because the application, I cannot ask my development team to stop development and don't change the application just because my tests are breaking. No, I can't do that, right? So writing XPath, writing CSS, or any locator for that matter is the basic problem, and that I will be trying to solve with this demo. So the basic criteria while choosing which AI I would like to demo is open source. I don't know, there are so many tools we already talked about, the companies and the tools they are providing. This is pretty expensive at this moment, buying a license and then using it. But at the end, is it really worth of spending that much money? That's a real question. So I have chosen only open source tools and technologies. So one is APM. Everybody knows APM. It's a mobile app automation tool. You can automate mobile web, mobile native app, or a hybrid app, or you can also go with a Windows apps automation as well. It has WinApp driver support. So it uses a machine learning model, which is MobileNet version 1. That is open sourced by Google. It's a deep convolutional neural network based on the TensorFlow framework. How is anybody working on TensorFlow already here? That's great. That's nice. Okay. I'm not expert into TensorFlow. Okay, so you can help me with the questions if there is any. So how it works? So what it does is basically what the test.io company has done is they have made a library. It's an open source library. We call that as a test.io classifier, test.io classifier. And that classifier library can be integrated with APM, because APM recently, Jonathan Lipsey added a functionality to add a custom locator or custom plugin to the APM so that you can have your own logic to locate an element. So this is how it works. So what it does is it has a test.io classifier has a pre-trained model with some labels. There are 105 labels, for example, cart, edit, Twitter, Google image, left arrow, right arrow, this kind of mobile apps icons. And that model is already trained on that. So if I'm specifying, I want to click on cart, so the model basically takes a snapshot of your application. It finds out all the elements. For every element, there is a snapshot, and that snapshot is matched with the model, and model basically gives me the percentage, how much match is found. If the match is above 20%, it is considering it is matched, and the highest matching element is returned, and I will be performing action on it. So what classifier plugin does, as we discussed, this is a traditional way of writing a locator, which I see is actually a problem, from my perspective. Instead of that, you can just simply say find element by custom and mention the plugin name, which is AI in test.io classifier, and then mention which label you want to perform action with. So this is just to give you a glimpse how it works internally. Won't be taking much time. This is your application screen. For every element, it captures snapshots. That snapshot is matched with the model. Model basically compares that image and try to find out what it is. Is it a left arrow? Is it right arrow? Is it up arrow? Is it something else? For every label, it gives the percentages, and the highest matching percent element is actually returned. So I will come back to this presentation and we'll talk about it. But before that, let me just show you a demo. I have a few things ready at my system. This one is a code from APM. What it does is it's very simple code. We have desired capabilities that will run on Android emulator. What is different is this. I have added a custom plugin from test.io classifier. And then while locating an element, I'm simply saying driver.findElement by mobile by.custom, or you can simply say driver.findElement by custom. Both options are available, and specify the locator as AI:search, and then perform an operation. That will return a web element and perform the operation search. Similarly, I have done the same thing here. So I'm searching a Bluetooth icon, and sorry, not here, this line. I'm saying that AI model to find out Bluetooth icon from my screen and then perform a click. Now the benefit of this kind of script is it doesn't matter am I on Android or iOS app. Even though the Bluetooth icon slightly changes with respect to OS, still my model is going to work because it is already trained on all the possible or images combination, which is like thousands or hundreds of images. You can train your model by adding your own images also if it is not working for you. So and that's it, so let me just close this. I will be automating the settings app, which is installed with any Android phone. So what I'm going to do is launch the setting app, then go click on the search icon, identify the search icon, tap on it, type Bluetooth, and then check for the Bluetooth icon from the search result, and then click on a Bluetooth icon and just check the screen title. All right, and it just clicked on Bluetooth, and then I'm checking the screen title is, the connection preference is actually shown as the screen title. Now, the question is how it is AI, how it is using ML. Going back to presentation. So this is a sample data. Now, when somebody is claiming AI, the very first thing my question is, are you using a machine learning? If you're using machine learning, which model are you using? Is that model is trainable? How can I train that model? What training data you can provide to that model? So this is just an example. When I say a search, so these are few sample data. This is again open source because I'm a big fan of open source. To train the model on a search data, I'm not going to show the recorded demo.
Because it won't.
Yeah. There are some other companies which also does the same kind of thing. So MicroFocus UFT, which is formerly known as QTP, it also has that similar kind of a feature where there is an AI utility, and I'm just saying profile and perform a click on it, which is cool, nice. I would be, I'm not sure if that model is really trainable, so you can train it on your custom images or not. AI categories in testing. Okay, so this is a kind of a conclusive slide for this part. So there are, from our perspective, there are actually 3 categories in AI because it's very hard to define the AI term. So first one is a smart tool and some smart framework which does a job for you, which looks like or which mimics some human behavior. For example, self-healing test. A self-healing test is like using multiple locator and falling back to another locator if the one is not found. Or the test defect mapping. As soon as a developer marking the defect as a fixed, the Jira should automatically trigger the respective associated failed test cases, run it, and that result should come back to the Jira, and the developer should be able to see immediately whether is it really fixed or not. Processing application log, and then identifying what is the flow chart, and then from that log creating a test cases. So these are just few examples which doesn't use a ML. In case of smart healing, it may or may not. That could also come in ML supporting role. Second category is tools with machine learning in supporting role. I'm saying machine learning, but in supporting role, not as a primary driver of my automation. So a few examples are visual regression, comparing a snapshots, finding out if the layout is broken or some elements are missing, or or some color issues are there on my web page. Image comparison recognition, yeah, I talked about it. Object element recognition, we just now saw a demo from test.ai classifier, and test data generation, we talked about that as well. Last one is, which I say as a holy grail of automation testing, where just provide the application URL to my AI, to my robot, and that will do the testing itself. Whether it will write test or no, I don't care, because I just want the bugs. We haven't reached up to that level. I haven't seen any tool. If you haven't seen, which is good, but you should probably ask these questions. Are you using an AI? If there are some models used, what models are used? is that model is trainable? How can you train the model? What is that training data set? Can you create your own data set and train it and then use it, customize a model? So these are the few questions. If you are attending any kind of presentation or demo, then you should be asking this question to a presenter. I think we help you to clarify what is AI in testing at right now. We'll move on to the next topic, and I would like Pankaj to take this next topic.
Yeah. So, in all, AI is something that is possible, but we are not still there. Okay, let's quickly talk about reporting and metrics. There has always been saying that you have to think out of the box, right? What is that out of the box you have to think to generate and decide your readiness of your releases? And there are a bunch of QE metrics we see all over the place. Somebody's trying to follow some SLAs, somebody's trying to follow some test metrics, somebody's trying to follow some operational metrics. So let's quickly talk about that. How, and why you need those things there as well. So I generally like these terms very much because the product quality, code quality, operation quality, process quality, and security. As a quality engineering team, we should look at all these metrics. Generally, that is not happening. What we do is we just end up doing, okay, my number of test cases failed versus passed, or my number of defects or my escape defects. Are we really talking about the release readiness or deployment readiness or technical readiness? Now, we have to decide when my product is technically ready to move to the next stage, when my product is technically ready for my deployment readiness, and then it is ready to release, right? So we have done a lot of brainstorming around that. You can see the picture next there, and we were discussing, understanding what exactly we can capture and what we can decide on. So can these things be automated? Yes, it is automated, and we have done that. We have captured. So what is important is you need to understand what are the tool sets you have. You need to understand what are your data sources are, and then you also have, a lot of tools are the integration points. You can either have APIs or some other way you can integrate each tool to push the data into your designated or required database or data source, right? And you can use KPIs to define what you want to measure out of those metrics and take decisions on it. And then that help you for your corrective and preventive actions to have a continuous improvement in your process or in your product or your operation activities. I'm going to show some metrics that we have generated and we've been using thoroughly in our organization. Some data I have removed from the slides, not to show you what we are doing there, but there are enough information you to understand what we got there. So this is a Jira dashboard. So we know that if you have a Jira on cloud or in premises, it's always becomes a difficult what exactly I need to capture using existing Jira dashboards, right? It's always a challenge. So what we did is we actually pulled the data from Jira into the data source, and we have this process automated. We have Jenkins job running every day, pulling that data what we need and just present this data in a 24 hours. So you can get your defect severity, priority, you can get your test cases versus defects versus epic versus stories, and understand that you can really tag them as a sprint level and understand what you can really doing in the sprint as far as the quality is concerned. Further, it's a escape defect by line of business or projects or whatever you can really think of, and you can categorize those accordingly and then see where the problems are and pick up those. And escape defect is always a painful. You have incidents reported in some other system like maybe ServiceNow, and then you need to understand whether those are really issues at technology team level. So you can categorize those and see here as well. Further, you have your automation test versus manual test, and understand whether how much automation percentage I have in my project and how much automation coverage I have, so I can really justify the automation and the readiness for my either deployment or release readiness. This is the automation dashboard where you can see how many tests you are running. You can see here total test pass versus fail. You can give a date wise or week wise or month wise or last 1 hour and find out what is happening there. Further, if you see this section, you can really see how many test cases of failed because of what error. And you can really capture that and really see, okay, this test is failing for a longer time. Every day this test case failed. The number of fails and the build. You can also get the build number from Jenkins as well, because you're pushing that data from Jenkins to data source, whatever you're using. This is the one which I was talking about, that you have the Jenkins build, you have the test error versus the error message, and then you can further go into all those details and find out, okay, this build, this test case was failed 34 times, so I can really go and check that. Further, Git data as well. You can pull the data from Git. Git also supports APIs. Get that data, see how many commits are happening, how the reviews are happening, and do we really need to focus on any issues in terms of the Git commits as well as reviews. This is very important when it comes to the code review and any review activity in the development team as well. Further, vulnerability management report, you can get that report as well, and use that as your one of the decision making point in your discussions. So I have specifically removed the names there. You can have the build metrics as well. How my Jenkins is performing, how many jobs have failed, in a day, or you can see the drain. I can see that sometimes it is 96%, sometimes it's just 20%. So there is some problem with the Jenkins, either network issues or either server issues or something else which really highlighted me, and I need to really focus on those kind of projects or jobs in Jenkins to find out what are the build issues. SLAs, you can pull the information from ServiceNow, find out what SLAs are, what are the incidents are, what are the change success rate is, and MTTR and everything else, and that's easily available. And this process is automated. We are using BigQuery as a data source for all this data, and we are pushing all this information into BigQuery on cloud, and we are using that as a data source to show this all information. So that's all about metrics. We have some references. Of course, we'll share the slides. You can go through some references for your future innovations. And that's all. Cool.